Hey guys, welcome back. So after completing the course, we are now doing this question and answers session. So I want to show you some of the very important data science interview questions. Okay. So when you complete the course, get the certificate and apply for jobs on data science, you must be very comfortable with doing the data science projects. But apart from that, you need to have the answers in place for any questions that are asked in the interviews. So let's start the session. So how do you define data science, right? So you should have a strong, you can explain data science for a lot of time, but you need to use it properly with some specific keywords. So as the data science continues to evolve as one of the most promising and in-demand career paths for skilled professionals. So today, successful data professionals understand that they must advance they must advance past the traditional skills of analyzing large amounts of data, data mining and programming skills. So the data science, what is the definition then? So you can say that data science is an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from structured and unstructured data and apply knowledge and actionable insights from data across a broad range of application domains. So it's dependent on data mining, machine learning, and big data. Okay, so this is the definition of data science. Then the data scientist, this term was coined recently when companies realized the need for data professionals who are skilled in organizing and analyzing massive amounts of data. So in the past decade, data scientists have become necessary assets and are present in almost all organizations. These professionals are well-rounded, data-driven individuals with high-level technical skills who are capable of building complex quantitative algorithms to organize and synthesize large amounts of information used to answer questions and drive the strategy in their organization. This is coupled with the experience in communication and leadership needed to deliver tangible results to various stakeholders across an organization for business. Okay, so this is a little introduction about data science. Okay, next we will see what is logistic regression in data science. So logistic regression, as the name suggests, it's a regression, and regression is a type of supervised learning. All right. So let's see some information about logistic regression. So when we work with machine learning models, one question that generally comes into the mind for a given problem is whether I should use the regression model or the classification model. So in simple terms, If you have a data set with marks of a student in 5 subjects and you have to predict the marks in another subject, then it will be a regression problem. On the other hand, if I ask you to predict whether a student is pass or fail based on the marks, it will be a classification problem. So to our surprise, logistic regression is actually a classification algorithm. So we have some issues with linear regression, and to overcome the issues with linear regression, we can use this logistic regression. For linear regression, the cost function is mostly we use mean squared error represented as the difference between the actual values and the predicted values iterated over all data points. And then you do a square and take the average. It is a convex function. And this cost function can be optimized easily using gradient descent. So how to define logistic regression then? So logistic regression was used in biological sciences. It is then used in many social science applications. So the logistic regression uses this sigmoid function. Okay. So we have the logistic regression. The different types of logistic regression are binary logistic regression, then multinomial logistic regression. So it's another technique borrowed by machine learning from this field of statistics. That is the logistic regression. So since it uses the logistic function, it is named as the logistic regression. So it uses an equation as a representation, just like the linear regression. So it models the probability of the default class. For example, the first class. For example, if we are modeling people's gender as male or female from their height, then the first class could be male, and the logistic regression model could be written as the probability of male given a person's height, or more formally, probability of gender equals male is given by the height. So just find out more information about logistic regression and try to solve it using some examples. The next question: name the 3 types of bias that can occur during sampling. So what are the 3 types of bias that can occur during sampling? So just see the slide, just see the picture. So in the sampling bias, in the sampling process, there are three types of bias, which are the selection bias, under coverage bias, and survivorship bias. Okay, so what are these? What do you mean by these? So sampling bias occurs when some members of a population are systematically more likely to be selected in a sample than others. It is also called ascertainment bias in medical fields. So, sampling bias limits the generalizability of findings because it is a threat to external validity, specifically population validity. So, the selection bias. So, people with specific characteristics are more likely to agree to take part in a study than others. People who are more thrill seeking are likely to take part in pain research studies. This may skew the data. Then, if you take under coverage bias, then some members of a population are inadequately represented in the sample. Administering general national surveys online may miss groups with limited internet access, such as the elderly and lower income households. Then we have this survivorship bias. Successful observations, people and objects are more likely to be represented in the sample than unsuccessful ones. In scientific journals, there is strong publication bias towards positive results. Successful research outcomes are published far more often than null findings. Okay, so I just gave you the examples of each type of this bias. So now let's see the definition of each of these. So first is, what is selection bias? So selection bias is an experimental error that occurs when the participant pool or the subsequent data is not representative of the target population. Okay, so this is selection bias. Then what is under coverage bias? So under coverage bias is a type of sampling bias that occurs when some parts of your research population are not adequately represented in your survey sample. Okay, then finally, survivorship bias. So what do you mean by survivorship bias? So we can define survivorship bias, that is the logical error of concentrating on the people or things that made it past some selection process and overlooking those that did not, typically because of their lack of visibility. Okay, so next comes the decision tree algorithm. So we will have a detailed discussion about decision tree later. So first, let's see what is the meaning of decision tree algorithm. So decision tree is again a classification algorithm. So classification is basically is a supervised machine learning or data science. Okay, so decision tree is a very popular and very simple algorithm for classification. So they are the type of supervised learning where the data is continuously split according to a certain parameters. The tree can be explained by two entities, that is, decision nodes and leaves. The leaves are the decisions or the final outcomes, and the decision nodes are where the data is split. So we use this concept of decision tree a lot of times in our daily life. So I will explain you in detail when we go to the next question after this supervised and unsupervised. So now supervised and unsupervised learning, very important for any interview. So supervised learning, as the name suggests, uses the labeled input and the output data, whereas an unsupervised learning, it does not use the labeled data. Okay, so that is the starting definition. So when we use supervised learning, we are training our machine by giving it both inputs and outputs. Okay, and we are making the machine more trained or more confident. Then when we give a new set of inputs, the machine will be able to predict the proper output. So this happens in the supervised learning. So you can see in the picture, it's a task driven. So you can give feedback at the output or at the end of the supervised learning, whether the prediction is correct or not. So the feedback will be given in the case of supervised learning. So it's a pre-categorized data. I will give you 10 images and say it's a dog, and I give you 10 images and say it's a cat, and then I give you a new picture. You should be able to find out whether it's a dog or a cat. So I trained you by giving both inputs and outputs. Then I say I will give you a new input, you need to predict it. If you wrongly predict it, then I will give my feedback that your prediction was wrong. So that is precisely the supervised learning. So we have classification and regression in supervised learning. So the classification is discrete values, where we deal with discrete values like male, female, true or false, 1 or 0, accept or reject. So these are the examples of classification. Whereas the regression, when we deal with continuous values like height of a person, weight of a person, amount of rainfall, the stock market prices, all these are the examples of regression. Then in unsupervised learning, it's a data driven. So here I will not train the machine by giving the input and output. I just give you a chunk of data from which you need to find out the patterns hidden in it. Okay, so it's data driven, and I cannot give you any feedback on the patterns that were discovered. All right, because it depends on the interest of the people. If I give you a data, you will be interested in the phone numbers of the customers, some will be interested in the age of the customers, some will be interested in the buying behavior of the customers. So that is unsupervised learning. So in unsupervised learning, we have clustering, we have association, and we have dimensionality reduction. Then you can see the differences, some listed differences about supervised and unsupervised. All right, now let's go to the next question. decision tree. Explain the steps in our decision tree. As we said, decision tree is a supervised learning technique that can be used for both classification and regression, but it's mostly preferred for classification problems. It is a tree structured classifier with internal nodes representing the features of a dataset. Branches represent the decision rules, and each leaf node represents the outcome. So you can see all those things in the picture. The leaf nodes that you see at the extreme bottom are known as the outcomes. You will get yes or no in the outcomes. The remaining are the internal nodes representing the features of the dataset. The branches represent the decision rules. Okay. In a decision tree, there are two nodes, the decision node and the leaf node. Decision nodes are used to make any decision and have multiple branches, whereas leaf nodes are the output of those decisions and do not contain any further branches. The decisions or the test are performed on the basis of features of the given data set. It is a graphical representation for getting all the possible solutions to a problem on given conditions. We call it a decision tree because, similar to a tree, it starts with a root node, which expands on further branches and constructs a tree-like structure. It simply asks a question, and based on the answer, yes or no, it further splits the tree into subtrees. So we take the entire data as the input. We calculate the entropy of the target variable as well as the predictor attributes. We calculate the information gain of all attributes. Then we choose the attribute with highest information gain, and that becomes the root node. So when we are supposed to construct a decision tree, we will be in a great confusion of which node, which attribute to pick as the root node. So here is where we use the concepts of entropy and information gain, so that we have seen in our course what is an entropy and what is an information gain. And an attribute with highest information gain is chosen as the root node. Okay. So the root node is from where the decision tree starts. Okay. It represents the entire data set, which further divides into two or more homogeneous sets. The leaf node are the final output, and the tree cannot be segregated further after getting a leaf node. Splitting is the process of dividing the decision node into a subnodes according to the given conditions. Then the subtree is a tree formed by splitting the tree. Pruning is the process of removing the unwanted branches from the tree. The parent or the child node or the parent node, it's the root node of the tree, is called the parent node, and other nodes are called the child nodes. Okay. So these are the steps, and this is quite about the information about the decision tree. Then how to avoid overfitting in your model. So overfitting is generally a negative impact. It will impact your model. So it's overfitting is a significant practical difficulty for the models and many other predictive models. Overfitting happens when the learning algorithm continues to develop hypotheses that reduce training set error at the cost of an increased test set error. There are several approaches to avoid overfitting. So when it comes to decision trees, then how to avoid overfitting in decision trees. So the first is tree pruning, that stop growing the tree earlier before it perfectly classifies the training set. Then the second step is post pruning. This allows the tree to perfectly classify the training set and then post prune the tree. All right. So when it comes to any model, when it comes to how to avoid the overfitting in any general model, then we have something called as cross validation, which is a powerful preventive measure against overfitting. We can train with more data, but it doesn't work every time. But training with more data can help algorithms detect the signals better. We can remove the features. Okay. So let's say we want to predict if a student will land a job interview based on the resume. Now assume we train a model from a data set of 10,000 resumes and their outcomes. Next, we try the model out on the original data set and it predicts the 99% accuracy. But now, when we run the model on a new data set, we only get 50% accuracy. So our model did not generalize well from our training data with the unseen data. So this is what we define it as overfitting. And it's a common problem in machine learning or in data science. Overfitting occurs in the real world all the time. You only need to turn on the news channel to hear the examples. So in overfitting, we have to understand the signal versus noise. In predictive modeling, you can think of the signal as the true underlying pattern that you wish to learn from the data. Whereas noise, on the other hand, refers to the irrelevant information in a data set. Okay, so the signal is a true underlying pattern, whereas the noise is a irrelevant information. So here we have understood some questions on the interview for data science. So you can just practice these many questions and we will be back with other set of questions and we will have them and we will have a good discussion about those questions in our next session. All right. So any queries you have, you can write to us. All right. Thank you.